When reusing existing one-phase feeders for a new three-phase panel, it's crucial to address several National Electrical Code, or NEC, concerns. Firstly, consider the panel rating. The existing panel must be adequately rated for the total load of the new three-phase system. This includes accounting for all connected devices and equipment, ensuring the panel's capacity is not exceeded. Secondly, examine circuit protection. The existing one-phase feeders must be protected by appropriately sized circuit breakers or fuses. These protective devices must be rated to handle the ampacity of the feeders, preventing overcurrent situations that could damage the wiring or create a fire hazard. Thirdly, evaluate conductor ampacity. The existing one-phase feeders must possess sufficient ampacity to carry the load imposed by the new three-phase system. Conductor size directly affects its ability to handle current without overheating, so proper sizing is critical for safety and reliability. Fourthly, address neutral conductor sizing. If the new three-phase system requires a neutral conductor, the existing one-phase feeders may lack one or have an undersized neutral. An undersized neutral can lead to voltage imbalances and potential equipment damage, so this aspect must be carefully considered. Fifthly, ensure proper grounding. The new three-phase system must be grounded in accordance with NEC requirements. This may involve modifying the existing grounding system to provide a safe and effective path for fault currents, minimizing the risk of electrical shock. To resolve these code compliance issues, several solutions may be necessary. Firstly, upgrading or replacing the existing one-phase feeders may be required to meet the demands of the new three-phase system. This involves selecting conductors with appropriate ampacity and insulation ratings to handle the increased load. Secondly, installing additional circuit protection devices may be necessary for the new three-phase feeders. This ensures that each circuit is adequately protected against overcurrents and short circuits. Thirdly, adding a neutral conductor may be required if the new three-phase system necessitates one. This involves running a properly sized neutral conductor from the source to the panel, providing a balanced return path for current. Fourthly, modifying the grounding system may be necessary to comply with NEC requirements. This could involve installing additional grounding electrodes, bonding conductors, or other measures to improve the overall grounding effectiveness. Several NEC articles are particularly relevant to this scenario. Article 220 covers branch circuit, feeder, and service calculations, providing guidance on determining the appropriate size of conductors and overcurrent protection. Article 250 addresses grounding and bonding requirements, ensuring a safe and effective electrical system. Article 310 focuses on conductors for general wiring, specifying ampacity ratings, insulation types, and other important characteristics. Article 408 pertains to switchboards and panel boards, outlining requirements for their installation, construction, and overcurrent protection. When performing load calculations, it's important to consider both the continuous and non-continuous loads connected to the panel. Continuous loads, which operate for 3 hours or more, must be factored in at 125% of the rated current. Non-continuous loads can be calculated at 100% of their rated current. The total load on the panel must not exceed its rating, and the feeders must be sized to carry the calculated load. When selecting circuit breakers or fuses, it's crucial to choose devices with appropriate interrupting ratings. The interrupting rating indicates the maximum fault current that the device can safely interrupt without failing. The available fault current of the panel must be determined through calculations or testing, and the circuit breakers or fuses must have an interrupting rating equal to or greater than the available fault current. Grounding electrode conductors must be sized according to NEC Table 250.66 based on the size of the service entrance conductors. Bonding jumpers must also be sized appropriately to ensure a lower impedance path for fault currents. The grounding electrode system must consist of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The electrodes must be installed in accordance with NEC requirements, ensuring good contact with the earth. When working with electrical systems, safety is paramount. Always energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Verify that circuits are energized using a voltage tester before touching any conductors or equipment. Follow lockout/tagout procedures to prevent accidental re-energization of circuits while work is in progress. Only qualified electricians should perform electrical work, as they have the knowledge, skills, and experience to do the job safely and correctly. Consult with a qualified electrician to determine the specific code requirements and the best solution for the renovation project. They can assess the existing electrical system, perform load calculations, and recommend appropriate upgrades or modifications to ensure compliance with the NEC and other applicable codes. It is important to remember that electrical codes are constantly evolving, so it's essential to stay up to date with the latest requirements. This can be achieved through continuing education courses, industry publications, and consultations with electrical inspectors. By adhering to the NEC and other applicable codes, electrical systems can be designed and installed safely and reliably, minimizing the risk of electrical hazards and ensuring the long-term performance of the system. Consider the voltage drop in the feeders. Excessive voltage drop can lead to reduced equipment performance and potential damage. NEC Section 210.19 AM provides guidelines for minimizing voltage drop in branch circuits, and similar principles apply to feeders. The length and size of the conductors, as well as the load current, affect voltage drop. Conductors should be sized to limit voltage drop to an acceptable level, typically no more than 3% for feeders. Consider harmonic currents in the system. Nonlinear loads, such as electronic devices and lighting ballasts, can generate harmonic currents that can overload neutral conductors and other electrical equipment. If harmonic currents are present, it may be necessary to oversize the neutral conductor or install harmonic filters to mitigate their effects. NEC Section 220.61 provides guidance on calculating neutral loads, taking into account the effects of harmonic currents. Consider the ambient temperature in the area where the feeders are installed. High ambient temperatures can reduce the ampacity of conductors, requiring larger conductors to be used. NEC Table 310.15 Bone provides correction factors for adjusting conductor ampacity based on ambient temperature. Consider the directing factors for multiple conductors in a raceway or cable. When multiple current-carrying conductors are installed in the same raceway or cable, their ampacity must be directed to prevent overheating. NEC Table 310.15 Cone provides directing factors for various numbers of conductors. Consider the type of insulation on the conductors. Different types of insulation have different temperature ratings, which affect the ampacity of the conductors. NEC Table 310.104 lists the various types of insulation and their temperature ratings. Consider the grounding electrode system. The grounding electrode system must be properly installed and maintained to provide a low impedance path for fault currents. The grounding electrode system should be inspected regularly to ensure that it is in good condition. Consider the bonding of metal enclosures and equipment. All metal enclosures and equipment must be properly bonded to the grounding system to prevent electrical shock hazards. Bonding jumpers must be sized according to NEC Table 250.102 Kern. Consider the use of ground fault circuit interrupters, or GFCIs. GFCIs are required in certain locations, such as bathrooms and kitchens, to protect against electrical shock hazards. GFCIs should be tested regularly to ensure that they are functioning properly. Consider the use of arc fault circuit interrupters, or FSIs. FSIs are required in certain locations, such as bedrooms, to protect against fire hazards caused by arc faults. FSIs should be tested regularly to ensure that they are functioning properly. Consider the labeling of the panel board. The panel board must be properly labeled to indicate the circuits that it serves. The labeling should be clear and easy to read. Consider the working space around the panel board. Sufficient working space must be provided around the panel board to allow for safe access and maintenance. NEC Section 110.26 specifies the required working space. Consider the height of the panel board. The top of the panel board should not be higher than 6 feet 7 inches above the floor or working platform. NEC section 404.8 specifies the maximum height. Consider the lighting in the area of the panel board. Adequate lighting must be provided in the area of the panel board to allow for safe access and maintenance. NEC section 110.26d specifies the required lighting. Consider the ventilation in the area of the panel board. Adequate ventilation must be provided in the area of the panel board to prevent overheating. Consider the presence of any hazardous materials in the area of the panel board. If hazardous materials are present, additional precautions may be necessary to ensure safety. Consider the coordination of overcurrent protective devices. Overcurrent protective devices should be coordinated to ensure that the device closest to the fault opens first, minimizing the extent of the outage. Consider the use of surge protective devices, or SPDs. SPD can protect sensitive electronic equipment from damage caused by voltage surges. Consider the use of uninterruptible power supplies, or UPSs. UPS can provide backup power in the event of a power outage. Consider the use of energy management systems, or EMSs. EMS can help to optimize energy consumption and reduce energy costs. Consider the use of smart meters. Smart meters can provide real-time data on energy consumption, allowing for better energy management. Consider the use of renewable energy sources, such as solar and wind power. Renewable energy sources can help to reduce reliance on fossil fuels and lower energy costs. Remember to consult with local authorities and obtain any necessary permits before starting any electrical work. It is crucial to document all electrical work performed, including load calculations, wiring diagrams, and inspection reports. This documentation can be helpful for future maintenance and troubleshooting. Remember that the NEC is a minimum standard, and it may be necessary to exceed the NEC requirements in certain situations to ensure safety and reliability. Always prioritize safety when working with electrical systems. If you are unsure about any aspect of the work, consult with a qualified electrician. Proper planning and execution are essential for successful and safe electrical installation. By carefully considering all of these factors, you can ensure that the existing one-phase feeders are safely and effectively reused for the new three-phase panel, complying with all applicable codes and standards. This information is for general guidance only and should not be considered a substitute for professional advice from a qualified electrician or engineer. Always consult with a qualified professional before undertaking any electrical work. Failure to do so could result in serious injury or property damage.